The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Alrighty. Thanks everyone for coming. Appreciate you being here, and I'm going to talk to you a bit about a paging system that I was hoping to have more completed than I do at the current moment that we are, but so is life. So a little bit of background about me. My name is Neil Hanlon. I'm an open source systems engineer at CIQ. CIQ is one of the principal and founding sponsors of the Rocky Linux project, and they pay me to work on Rocky Linux and do kind of silly stuff like this. I'm also one of the founders of Rocky Linux. That happened before I started working at CIQ. I also do amateur radio, and you can find my complaints on Blue Sky. Why are we here? OpsGenie is dead. OpsGenie was a startup that got bought out by Atlassian like 5-ish years ago. They made a product that was kind of a competitor to PagerDuty, little more easy to use, DevOps focused, insofar as DevOps is a thing that can be a word, and they're getting rid of it. They announced recently that they're going to be sunsetting OpsGenie, as they've essentially rolled all of the features they think into the Atlassian products, either Service Desk or directly into Jira and some other kind of incident management stuff that they have. The long and short of it is that we still need alerting, and we need to replace it. And it needs to be kind of effective. I personally have come from a background of being on call for like 2 years straight at one point, and that's just never fun, especially when the alerts are never actionable or almost always never actionable. And so having something that is very effective and has a low signal to noise ratio is really important. Because especially we're working with a bunch of volunteers. I'm one of, if not the only person paid to work full time on Rocky and receive pages, and it's not really fair to ask other people who aren't getting paid to wake up in the middle of the night for crap. So Rocky has infrastructure spanning across different clouds. We're in AWS, we're in Google Cloud, we have some stuff in Oracle, we have stuff in private clouds and other CSPs. We have things in physical data centers that we have to make sure are secure and are monitored and are connected. We have multiple architectures. We have x86-64, PowerPC, ARM64, S390X, and recently with Rocky 10, we have added RISC-V 64 to that lineup as well. And also, a lot of this infrastructure is not in the same place, and we have to deal with different regulations from different countries, especially the US with EAR and ITAR. Not strictly relevant necessarily to monitoring, but it does play some complications into where we're able to host and put things. Along with that, we need on-call scheduling. We need notifications of incidents and visibility into the monitoring that we're providing on these services and servers. And we need the escalations to not be spam. We need to have them be highly actionable and for them to contain all of the information that a responder would need to action that alert, do something, and fix the problem. We could have just gone with PagerDuty or another solution, and we probably should have. But that's not why we're here. So this is what our replacement stack is looking like. Some of this already existed, like Prometheus and Alert Manager, where we are firing from Prometheus and Alert Manager into OpsGenie, which would then fan out into various locations. What's changing here is that iris.claims and oncall.tools are replacing OpsGenie for the alerting and incident management parts of this. I'll get into kind of what these components are in a second if you're not familiar with them. But generally, the flow is that Prometheus would be monitoring something. If it detected something that would be wrong or was in an alert condition, it would go to Alert Manager. Alert Manager would then dedupe and do some other stuff. And ultimately, the end goal is that someone gets an alert that they can do something with, right? And that can be either via email, SMS, or voice, or MQTT, which is one of the things we're going to talk about today. We also have a bunch of ops tools that we're still using, like Ansible and Grafana, as well as Loki and OpenSearch for logs and visibility into those. So, who here's familiar with Prometheus or Alert Manager? Okay, cool, great. So, for those that don't know, Prometheus is a time series database and monitoring system. You can use it to do pretty much anything you want. You scrape metrics from the services. Generally, you don't push into Prometheus, though you can. And there's other components like Mirror that you can add on to it afterwards or at the beginning to enable you to scale horizontally and have um, more resilient and highly available monitoring, basically. And Alert Manager is another component that's part of kind of the Prometheus stack that dedupes, inhibits, silences, and groups your alerts so that you're not getting 1,000 alerts when you have a data center go down, but you might get one alert saying that all of the stuff is down because the network is out. And it helps to centralize alert delivery and incident management. It can directly route to notification channels, so you can go to Slack, you can go to OpsGenie, you can go to a lot of different places, including Iris, which is the next thing we're going to talk about. Both these tools, Iris Claims and On-Call tools, were developed by LinkedIn. These are actually their URLs, so if you want to look them up, you can just go to iris.claims and oncall.tools. They work in conjunction with each other, but you do not have to use them with one another. Iris handles incident notification and management. So what happens really is that you get Alert Manager to fire off an alert into Iris, where it creates an incident and enriches the Alert Manager rules with stuff like who's on call, who should get notified, where are those notifications supposed to be going, instead of it just going to a generic place. And you can still send them to a generic place like Slack or a Telegram or Matrix group or something like that. But if you want to send it to a specific person and not have a lot of noise that everyone needs to see, this can help. And On-Call Tools works with that to have a self-service way for users that are on call to manage their schedule, do overrides, add vacations, sync their calendars if they are, going on vacation and need to do some work there. And as we're a community project where we want to have people that are volunteering to do this and not taking up all of their time, we want to be able to have a system that is calendar based and integrates with their life and schedule, and honestly my life and schedule as well. And like I said, it hydrates Iris with this up-to-date information about who's on call, if there's any overrides, and the like, so that when an alert comes in or when an escalation comes in, it knows what to do with that information. These are just some stock screenshots from the docs for Iris, showing a plan, which is kind of the fundamental base unit in Iris that you use to define like where things go. My HDMI has been a little weird, but that's okay. And then on call, it's a calendar. You can show who's on call for what and where, and manage where your notifications are supposed to go. See when you're on call next, all that sort of fun stuff. So inputs and outputs. We talked a little bit about Prometheus and how to get data from servers into Prometheus. We have things like just scrape targets and pulling like node exporter from a server. We do that a lot for all of our metrics. We also have open telemetry from many applications that we deploy, like our build system. And we gather stuff like disk usage and load average and all the fun things that you don't want to get woken up in the middle of the night about. You'd rather get woken up 6 hours before and fix that, or maybe not woken up, but page 6 hours before and respond to that to go fix the issue when the disk is filling up or whatever the situation is. We also monitor a lot of service-specific KPIs that aren't necessarily OTel. Things like metrics from Go servers on like our Mattermost instances and other things that are exposing custom metrics that aren't going to be pulled out in traditional, OTel exporters. And then we have a lot of cron job stuff that fires off alerts into various locations right now, but it's not homogeneous. And part of this is going to be homogenizing that into a single output that we can notify all the stakeholders, even if they're not necessarily on call, but they just want to be notified of like, hey, a compose is happening, or it failed, or, we're cleaning up temp. I don't know. In terms of notification channels, Iris has a bunch built in, like email, just via SMTP, voice and SMS with Twilio, and it can do Slack, and Mattermost, which is what Rocky uses, happens to just accept Slack as an output, but we can do some more stuff with MQTT. And who's not familiar with MQTT? Is anyone familiar with MQTT? Some people. Okay. So get into it a little bit, but we already use a lot of Mosquito MQTT inside Rocky for messaging and notifying different services that things are done and we're ready to be consumed by another process. And so it works really as a nice glue for doing a lot of things that are absurd and not really supposed to be done. I put some examples here. Some of them are real, some of them are aspirational. MQTT is a pub/sub based system where you publish messages in and are consuming messages out of them. So you have publishers and consumers that allow you to decouple your infrastructure from the actual alerts that are happening or actual things that are happening. So it doesn't need to be in a single cloud. It doesn't need to really be anywhere. And using MQTT as the base for fanning out like this means that we don't have to keep modifying something like Iris, even though it does have plugins, but we can instead modify our bridge, our party bus, to fan out to wherever we need to go to. And like I said, some of these are real, some of them are fake. I actually have some restaurant pages up here. And I can, page them all out if they want to go off. This might not be very realistic, but I thought it would be kind of fun if we were all like the Rocky table, right? We're all at the booth here. And let me turn all these off while I beep in my hands. Someone comes over and has a question about free IPA, and we have a guy who's really good at free IPA, but he's not there, so we can just page him. The other idea is just like a bunch of us are already around Rocky and doing events like this, and it's just kind of fun to mess around with this stuff. I actually just triggered that from a flipper behind my laptop here. There's a bunch of different stuff you can do. We'll get into some of the other things here, especially around like Home Assistant and some other things that are maybe a little bit more realistic for end users. And I had some demos that I was going to plan or do. That's part of one of them. We had a really busy schedule with Rocky and releasing 10, and unfortunately, I didn't get to glue all of this together as much as I'd like to. But we are going to get there because this is the future of where Rocky's paging is going. Not necessarily with silly $30 restaurant pagers I got on eBay, but specifically with Meshtastic. Is anyone familiar with Meshtastic? No? A few people? Okay, cool. Meshtastic's a open source off-grid mesh communication using LoRa. It can be used in conjunction with the internet, and I think a lot of people myself included, question whether this is truly off-grid if there is a tie to the internet. Um, but it's pretty neat because it also uses MQTT, and the way that you can connect your devices. So I have a couple up here as well. People can come and play around with after. Um, you can originate messages into MQT if you have a device connected. So as long as you have your device connected to the internet, and it can be either connected over Wi-Fi, it can be connected over Ethernet, and you can also proxy via Bluetooth on your phone. If you can connect to an MQTT endpoint, and it doesn't even necessarily have to be on the internet. It could be at your home. It could be on your local LAN. It could be relatively local and deployed in such a way that it is fully off-grid and decentralized. You now have this way that similar in the 90s to where we had pagers and doctors were getting paged when they needed to be going to the OR or something. We have a system that supports end-to-end encryption. You don't need a license to use it, and you can do essentially whatever you want with it. And so I've been playing around with this over the past few weeks with a lot of degree of difficulty. There's not a lot of documentation that I can find on how to properly do this. There is documentation from Meshtastic, but what I found is it doesn't actually really work. Um, this snippet works like sometimes, and a lot of the time it doesn't. So I have been able to send messages fairly consistently, and then I'll reboot a device and it just won't work. So that's part of the struggle that I've been dealing with getting all of this working. But generally, using the MQTT integration with Meshtastic allows you to have a device that's not connected to a computer, because you can also control them serially. You can connect them with USB, and a lot of bots that run now will connect over serial and just fire off the commands, listen to messages that way. But to do it in a way that you don't need to have a physical Meshtastic device connected and that can be just done over the internet opens up a lot more possibilities in terms of routing alerts to people. So you could imagine your operations team has a channel. We have a Rocky Linux channel on Meshtastic that has a pre-shared key that we pass around to one another, and any device that's in that channel can send messages into it, can receive messages, and you can also orchestrate messages, or should be able to orchestrate messages via MQTT. The most important things are to make sure that you have, at least from my testing, and I'll update if I can, but you need to have OK to MQTT on. You need to have your server set up. You need to enable JSON output, and you also need to have a channel named MQTT. That's where you're publishing into on the topic. You see mesh US to JSON MQTT. I don't know why that's uppercase. It's supposed to be lowercase, but that's not why it wasn't working. But if you have that channel, it will downstream or downlink messages from MQTT and send them based on the metadata there. So we're sending to a channel with an index. We're sending it from a device. It has to be a device that exists. So you do have to have a Meshtastic device to insert those messages, but you're essentially just telling it what your gateway is to send it out. And then you can put whatever text you want, really. You can also include emojis. There's the ability to reply and react to messages as well. So that opens up the ability to process acknowledgments when someone, if you're sending it out to a group rather than an individual could acknowledge and accept that responsibility for that incident that you're working on, and notify the other people essentially that it has been acknowledged. Restaurant pagers. I did show that kind of silly example there. It's not as plug and play as I was hoping, which is why I just went for the brute force page everything at once. There was originally kind of a Flipper Zero app that I had found that said it would support this, and in reality, it appears that this specific model actually has different variations in it. So it's not the precise encoding that it's expecting, and I ended up just brute forcing it by scanning all of them and dumping them into a file and playing them out. So in the future, I'll probably look at doing some sort of hardware mod and making it actually useful in some way, mostly just for the fun of it.
What's the range on those restaurant pagers?
Not very. It's mostly limited by the question was, what's the range on the restaurant pagers, and it's mostly limited by the FCC and how loud you're able to blast that signal, and who's going to catch you, and if you can get away with it. It's those specific ones are on like 433 megahertz, so you can probably do reasonable line of sight. But with a antenna that's on that, probably wouldn't make it out of the building, if I had to guess. Um, but I haven't done any like actual range testing on it, which might be fun. Some other ideas I had were around POXAG, which is the paging protocol essentially for all of the pagers that people had on their hips. I struggled finding a pager in time for this demo, at least one that was not new stock. I kind of wanted something that was retro and not a brand new pager. There's a number of reasons that it's hard to find them, partially because they're just e-waste, and a lot of them don't operate on the ham frequencies that are needed for hampager.de, which is a amateur radio paging network that is mostly popular in Germany, as far as I can tell. But there are some transmitters as well in the US, and a lot of hotspots also support them. So if you have like a Shark RF open spot or a Pi-Star MMDVM hotspot for like digital mode radio stuff, a lot of them support paging. And personally, I have one in my car, or a hotspot in my car. I have a hotspot in my bag usually while I'm going around places. And if I had a pager, I'd be able to receive those alerts. The other thing, though, is I do carry a digital mode radio, and another option here would be to send out just SMSs via DMR radio to receive on my handheld there. More absurdity, radiograms. You can actually still send radiograms, and I'm able to send a radiogram anywhere in the world if anyone wants to. Talk to me afterwards. But, this could be a fun thing to do, maybe. I'm not sure anyone would actually appreciate it, but it could be fun to send out TLS expiration notifications via radiograms. And then some actually possibly useful stuff, like I had mentioned, the DMR SMS, but also Nifty. If you've not heard of Nifty, it's pretty nifty. And it's a service that is publicly available as software as a service, but you can also run it locally or on your own hardware or server, cloud, whatever. It's open source, and it's essentially open source push notifications for whatever platform you want to, and you can trigger them as easily as like piping to bash or piping to curl into a HTTP endpoint to send that notification. And you can use the public one, like I said. You can deploy it privately if you need to, and this is likely something we will add on to our paging system in the future, once we figure out exactly how we want to use it or something similar. On call at home. This was actually a real thing that happened to me. Not necessarily with a pager yet, but it did make my email go off for a solid 12 hours while I was not at home and made me panic. It turned out it was just a very wet day, and my French drain in my basement was just getting a little wet. But yeah, this was something that I thought might be really applicable to a lot of people. And there's a lot of ways, especially as Home Assistant and a lot of cloud-ish tools for your house utilize MQTT, and you have mechanisms to orchestrate these different alerts and paging and whatever else monitoring stuff that you need to do or want to do with the same infrastructure stack. I might be kind of the only crazy one that has Grafana and Prometheus and stuff deployed at my house and monitoring my like water meter consumption and energy consumption and stuff with RTL SDRs, but I don't know. Seems fun. What didn't make it? My demos. Radiograms, which is probably not a good idea. When linked to MQTT pipeline. I don't know. Email and off-grid something. APRS group messaging. You could use like CQ server to send out messages and spam a bunch of people that you know, hopefully. DMR SMS, pigeon relay, and the servo controlled bell thinning from the beginning. What we hopefully learned is that you can replace SAS alerting. Might not be very good, but you can replace it. Um, MQTT is a really good glue for pretty much everything. Hardware, especially if you're messing around with like LoRa and GPIO and triggering servo motors, is pretty fun. And I do think that pagers are going to live again. I think that we have the ability now to have these devices in a mesh where we're not relying on the internet and we're not relying on when Cloudflare went down last week and stuff didn't work. I think of that a lot. It's pretty terrible, I think, that we have gone back to centralizing all of the things to CDNs and individual services that can take us all out at the push of a button, and working to decentralize and have backup plans for our communications and our paging, and not just in our work but in our lives, is I think really important. And hopefully we can move towards less centralization of everything and hosting more things ourselves. Questions? Cool. You can find some stuff on git.resf.org/infrastructure.
I'll give you a question.
Okay.
So I just didn't want to jump in first. So if you were going to start off with this, where would you try to go to get started? Maybe digging into MQTT? Would that be the place to start?
I guess it depends on what you want to get started with. I kind of covered a wide array of things here and touched upon pretty much everything my mind was thinking about while writing the talk. In terms of the alerting pipeline and learning, like, Prometheus and Alert Manager and how those things work, I think the best way to learn is by doing. Honestly, Prometheus is kind of a bear, and so is Alert Manager. They're really easy to deploy and really easy to mess up the configuration of, and the documentation is very terse and not actually explanatory of what the rules and options and flags do in the real world. The on-call tools and Iris stuff is a bit nicer, but it does rely on kind of having the prerequisite stuff to feed into there. But at the same time, if you're trying to roll out like a solution just like personally, or for your home, there's a lot of tools that are actually built into Grafana as well for incident management that you can just utilize out of the box there. We chose to kind of go a different direction because we have so many different services feeding into it, but if you're largely bringing everything into things that can go into Grafana, Grafana has a really good incident management solution as well, that you can self-host and or use in their cloud. Yeah, in the back.
So what common setup does the average like food truck or restaurant pager system
Yeah.
have?
This is a pretty common one here. It's a Reticus unit. Get behind the speakers. This is an old one. They're still making these, basically. They're really simple things that just like have a battery and a little radio board in them, and they listen for a signal, and when they receive that signal, it goes off. So all of these units have like a different ID number on them. That's part of how the key gets generated to trigger the pagers. You can sync the pagers with them. A lot of them just look exactly like this, or they have like the puck setups and stuff. But they all work largely in the same manner, just triggering out those keys, and hopefully you don't have two restaurants right next to each other that have the exact same station ID. That would be unfortunate. Awesome. Thank you.